And hello, everyone, and welcome to our lunchtime lecture with Boise State's NASA Suits Challenge team, hosted by the Discovery Center of Idaho. My name is Emily Mahon, and I have the honor to serve as Education Director here at the Discovery Center. Today, we will be diving into 4 years of research by the Boise State University's NASA Suits Challenge team, who have been developing ARSIS, which is short for Augmented Reality Space Informatics Systems. Their team will share their process and do a live demonstration of it in action. Before I pass along the program to our special guests, I want to go through a few very important online etiquette tips and guidelines with everyone. Please make sure to keep your microphones muted and videos off. This will make it easier for us to hear what our guests have to share with us. If you have questions, feel free to type them in the chat box, but please only type questions or comments for the team that you would like me to ask during our question and answer time at the end. I've set the chat box so that all comments go directly to our team to prevent any spamming. So to begin, Suits, or Spacesuit User Interface Technologies for Students, is an annual challenge hosted by NASA to build AR, or augmented reality, software prototypes that can help improve autonomy, spatial awareness, communication, and navigation for astronauts on EVAs, or otherwise known as extravehicular activities in space and extraterrestrial surfaces, such as the moon. In answer to this challenge, the team has spent the last 4 years developing ARSIS, which again is short for Augmented Reality Space Informatics System. This system leverages augmented and virtual reality to create a telepresence communication system between the astronaut and mission control. Today, we are joined by Akaya Tullis, a senior majoring in Games, Interactive Media and Mobile, minoring in computer science with a business fundamentals certificate, Megan Lang, a sophomore in mechanical engineering, and Caleb Cram, a graduate student in Games, Interactive Media and Mobile, to explain what everything I just said means. So welcome, and thank you for coming today.
All right. Thank you, Emily, for the introduction. Sorry for that little kerfuffle right there with Zoom. So, as Emily introduced us, we're NASA Suits. We're a group on campus of students that tries to complete this design challenge every year. Today, we have a presentation for you where we're going to go over who we are, what we do, some more about the NASA Suits Challenge and the NASA Artemis mission in general, and then finish it off with a live demonstration of our software as it is today. So a little bit of context. So the NASA Artemis mission is a proposed mission that I believe originally was designed to get an astronaut on the moon in the year 2024. And as part of this mission, NASA's released a design challenge called NASA Suits, which has college students all around the United States design prototypes for ways that augmented reality can be used as a useful tool to help astronauts in the Artemis mission complete their responsibilities. So we can go a bit into the Artemis mission right now. So the Artemis mission is one of NASA's near-term priorities, and the whole goal is to create a permanent or at least long-term presence on the moon in order to get both economic benefit and to be able to secure passage further into space for later Mars missions. And there's a little quote right there. We're going back to the moon for scientific discovery, economic benefits, and inspiration for a new generation of explorers, the Artemis generation. While maintaining American leadership in exploration, we will build a global alliance and explore deep space for the benefit of all. And that's pretty much what the mission is in a nutshell. And if you have more questions about it, you can look it up online. They have all those resources available. So now we can go into NASA Suits and how that's applicable. So NASA Suits, we are not the only NASA Suits team. Different colleges all around the country do NASA Suits competitions. And the whole goal is to show how NASA can integrate augmented reality into essentially augmented reality HUDs for astronauts to complete navigation and task completion challenges. We're going to go into how exactly we're doing that right now.
Alrighty. Hi, I'm Caleb. So as we mentioned, we've been doing this challenge for a couple of years now. Specifically, we're going into our 5th year of the challenge. On the left of the slide, you can see a picture of the original team, actually, that first started working on this challenge and came up with the original concepts and prototypes. And then on the right-hand side, you can see a picture of last spring. We're doing some development right before our final testing. But yeah, and so each year it's been a very iterative process. We take what we built the year before and we go, okay, how can we improve this? What went wrong? What feedback did we get from NASA? Okay, how can we make this better? And it's been a really interesting process of improving through different types of new functionalities that we wanted, like adding like geology sampling tools and things like that, all the way to integrating new technologies. For example, when we first started the project, the devices that we're using right now didn't exist. I mean, 5 years ago, the HoloLens 2 and the Quest 2 were non-existent. In fact, the team was using a HoloLens 1 and an Oculus Rift S. And so we've evolved not just our software, but also the hardware we're using as the time has gone on. And it's been a really great learning experience of not just learning how to use this hardware and develop for it, but learning how quickly the technology industry changes and how to stay on top of that as someone who's working as a software developer. That's where this has been really good experience of kind of teaching like, hey, here's how you need to stay on top of this stuff. But yeah, we've done some really cool stuff. We've been able to keep iterating as time's gone on. But yeah, we can head on to the next slide. All right, so with presentations, we've done a lot of outreach events. We've done a couple, I mean, kind of similar to this one. We've done a couple with Discovery Center of Idaho. We've done this event called MockFest, which was super cool. It was like a big Lego themed event for a couple of days. A lot of cool Lego stuff there, and we were there just showing off kind of the systems that we built. And yeah, but the big thing with all these events is basically just letting other people get a feel for what we're trying, kind of like, be like, hey, here's what we're building, and sure, a lot of it's technical and chewy, but here's the cool part, and here's why that's useful to you, and like how this will impact you maybe in like 5 to 10 years, cool stuff like that. And then through the project, we've also had the opportunity to do a bunch of publications, which, I'll be honest, for me personally, I didn't really understand the validity of until I was pretty deep into college. And it's something that really, really does help boost your validity as someone in the field, in the industry, as like a researcher. And you can basically just write these professional publications that in very big technical chewy words describe what we're doing. It's a really cool opportunity. You get to go to conferences and present this work. Due to COVID, we haven't gone to as many of them recently, but I mean, if it weren't for that, we would have been in Japan last spring presenting some of our work, and we would have been in Copenhagen the year before that. And so it's really cool opportunities where it's like, you get to do this cool travel and learn a lot of stuff about a lot of cool things just because you did this interesting research. But yeah, it's been a lot of fun. We got to do a lot of cool stuff. But yeah, we can go ahead and head on to the next slide.
So this is the stuff going into specifically what we do. We work with 3 different applications. We have our HoloLens, a VR Oculus headset, and then we use Unity Desktop. They all serve a bunch of different purposes to help when the astronauts are going on their spacewalks and trying to communicate with their surroundings and with mission control. So the HoloLens we have, it's the HoloLens 2, and it has a word for it, like a drop-down screen where you can see the interface like real time. And sorry.
This is the HoloLens 2.
Yeah, we'll demo it in a bit. It shows a few different things within it. It'll tell the astronaut their biometrics. It'll map out their surroundings, let them know if their area they're in is safe. It will send waypoints to let them know navigation to get to certain areas. And it takes all of that information and it sends it back to the desktop communication, the Unity, with mission control so that they can help navigate them, send them to the correct areas, tell them, hey, we want you to go over here or do certain activities. And then our team specifically has the VR that we added in too. So it, on top of what Unity does, where it has the mapping, where mission control can see the terrain that the astronauts are in, we added in the VR so that they can be in the terrain real time. And as well as just the desktop application, the Oculus user can draw in the real world. They can set waypoints, little commands to say, hey, let's go over here and see what's going on. And that's for that specific slide. So next is the technical objectives. These are the things that NASA has asked us specifically that they want to see in our proposals or our developments for this year for each challenge. So specifically for navigation, they want terrain mapping and long short-term range. For mapping, like I said earlier, the HoloLens will collect its surroundings and map it out so that the desktop user and the VR user can see what's going on. And by that active mapping, they can set controls, know the areas. That way they can go directly to the points of the mission that they're trying to complete. We have long and short range. So if they're having to travel for long distance of time to get to certain samples. And then one cool feature that they added this year is called search and rescue. So on top of navigation to get to places they already know, whenever there's other astronauts out there, they want to be able to help them out if things go wrong. So they added in another point this year to let us know, so it'll send the information over from the other astronaut if something were to go wrong, so that they can go help them out. And then it'll send the navigation over of how to get to them. With communication, it's important that it connects back to mission control so that they can always be right there alongside with the astronaut. They can see on their screen the information that comes up and any objectives that are supposed to be completed. Our procedures, we have a few different ways that all the systems communicate together, specifically the HoloLens. They can use either hand tracking. It maps out your hands. It can see where you're going with that. So there's a few different commands that it can use with that. It can see where your eyes are looking to track that. And it can go by voice commands to open up different screens and manuals so that you can see your information, or you can see your biometrics. For geology, we have an option to get samples and to be able to identify what those samples are. There's different ways to get images and record that. And we're going to work on getting some telerobotics this year, a robotic system that can also aid in that. Then I think that's from, I don't know who's next.
All right. So we just got 2 more slides before the demo. We're going to go over the previous work that we've already done in our system and the main priorities for this next upcoming sprint. So ARSIS is a really big system. We've been working on it for 4 years. This is the 5th year now. So there's a lot of different features that we've implemented. So the first one is the mission control portals. The ability to have mission control see what the astronaut's seeing in virtual reality all around them has been huge for allowing them to be able to provide timely and useful contextually based feedback to the astronaut. Second is the AR menu, systems and behaviors. Augmented reality is a very new field when it comes to user interfaces. With mobile devices, we've pretty much got it figured out how buttons work, how forms work, how text input works. That is not the case for augmented reality, which means that we've had to do a lot of experimenting to find a way to go through the menus and access all the features in a way that actually makes sense and is useful for the astronaut. The third is the VR telepresence technology, and this wraps in back with the mission control portals. This is the ability for the people in the VR to see the actual shape of the terrain that the astronaut is in, and you will get a chance to see this in the demo. The AR procedure display in space. Procedures, you can't just have a textbook of them because you've got very heavy gloves and frequently you need both hands. So bringing that into augmented reality is a way to allow astronauts to see real time which steps they need to take to complete their current procedures without getting in their way and without using too many hands. Redundant voice controls. Redundancy is good. NASA loves their redundancy. So we're trying to make sure, and for the most part we've succeeded, in making sure that every option in our system can be accessed in multiple ways, be that through virtual touch, eye tracking, or voice command. Path recording and playback, I'm not going to get too far into that right now because it's better seen in the demo. The XR Telestration tool, that is in the virtual reality portal. When the mission control sees the terrain the astronaut's in, we have a tool that allows them to actually draw things in that terrain that the astronaut can then see overlaid in real space. It's an incredibly useful tool for detailing like which door to go through or which path to take or any other sort of important thing. And you'll get a chance to see how that works in the demo. Basic navigation via minimap. This is one of the new features we added last year. It was inspired by minimaps in a lot of video games, which allows for very quick contextual knowledge of the player's location, as well as where important objectives are nearby. So we implemented one of those into the system, and so far it's worked very well for helping astronauts navigate to beacons. The interactive geology and sampling tool, that's a questionnaire that allows astronauts to record information about geology, which is one of the main priorities of the lunar or of the Artemis mission. And the usefulness of it is that it helps prevent missing information, or it helps prevent astronauts from forgetting a certain thing that should be included in the report. And it just takes the form of a questionnaire along with appropriate places to take pictures, as well as prompting on what sorts of pictures to take. Finally, the last big feature that we've created in the past is the biometric dashboard, which allows the astronaut to see the current state of their suit, as well as any biometrics that might be unusual will pop up as notifications or alerts. This helps astronauts be able to make sure that they don't get into a dangerous situation by being unaware of facts about their suit. So that's the previous work. We've got 4 main objectives, and this is something I'm excited about. This year, we've got 4 main objectives for what we're building. The first is the mini-map. We're going to make it more robust, and that means the ability to add or remove beacons, not before the mission, but during the mission, and be able to navigate to those beacons dynamically. Second is rover integration. We're going to add a remote control car to our system that the astronaut can then control from the augmented reality system. And this is going to help for both geology sampling or the lunar search and rescue or any other number of things. Third, we had the lunar search and rescue. This is a big priority put down by NASA for this year's challenge, which is the ability to find, communicate with, and otherwise assist in the rescue of people who have either been trapped or otherwise their suit is in a condition that means that they cannot get back to safety by themselves. And there's a lot of tools that we're exploring on this route, including real-time communication, the interactive beacons that we've mentioned before with the mini-map, and the rover integration. Finally, the diegetic UI implementation, which are some big words that I didn't know before this, which is just basically taking UI or user interface and bringing it into the real world. So with phones, you have menus and text input and buttons, and they're all just on a screen, and that's fine. But one opportunity that we have with augmented reality is the ability to take buttons and menus and bring them into something that's much more intuitive. One of the things we're exploring this year for the diegetic UI implementation is having buttons sort of on the arm of the astronaut that can then be touched in order to interact with the environment. And these can be contextual, they can change around based off of the context, or they could be static. We're still in the process of exploring that. But those are the 4 main priorities and the 4 things that we're working on for this year, ARSIS 5.0. So we have the demo.
All right, let's get it. I think we're about ready. Do you want to run the Hololens?
I was going to run OBS.
Oh, right.
And check for.
Okay.
But yeah, I can run the VR
Ground station. Oh, either
Yeah.
one. Yeah, one of the other. Whichever one you want.
Sounds good.
Just make sure these are both streaming.
Send a message.
Alrighty.
That's just inside here.
Yeah, what kind of?
Yes.
Oh, just share screen.
Yes.
Okay, perfect. Yeah, actually, before I do that. Can you hit share on the Oculus menu? All right. There we go. Got that running.
Cast
Yes, yeah, cast. Sorry, that's
to
what I meant.
computer. There you go.
Okay, cool. That's casting. There we go. All right, nice. Now, wait. Okay, there we go. I'm just gonna do this. All right, I'm gonna share a screen here. Sorry about the delays on that. Okay, let's try that out. All right, so can you all see the 2 different views? One from the VR headset and one from the HoloLens?
Can't see this stuff anymore, but
Why is that stopping?
That's okay. We'll just do one at a time.
There we go. All right. So the view with the little mini map is coming from the HoloLens 2. And so this is something that the astronaut would be using in theory. Is it updating on me? It's frozen.
yeah, it's frozen.
Okay.
Yeah, the preview only lasts 9 seconds. You should keep sending.
Okay.
Okay, we're saying one at a time. Can you swap OBS to not be showing the screen?
Yes, although we can just share the screen instead of OBS.
Okay,
Yeah, that's probably the better way to do it.
You want to swap that, or should I? Because I don't actually know where that setting is, so I'm gonna waste time looking for it.
There you go.
Sorry about this. We're hitting bandwidth issues, and it doesn't want to keep up.
Yes, so these issues usually don't show up unless we're trying to stream. And we're showing the Windows device portal first?
Yeah.
All right, cool. Let's take a look at that.
I'll probably close that again.
Yep.
Yeah.
Live preview?
They're only
How
previews for
buggy
9
this thing
seconds.
is. It's really irritating.
There we go. Coolio. All right.
All right. There's just a full screen button.
Yeah, basically, like,
Oh.
it only lasts 9 seconds. After 9 seconds, it'll keep ending.
Well, it should be fun now because that's the The problem is I was cast on too seconds.
Interesting. Oh, we're over the hurdle.
Yeah.
All right, we're experiencing bandwidth issues. Should we switch to video?
Show the Oculus.
Okay.
I'll figure this out.
Stop share. Yep. All right, so we're going to show the Oculus portal before. And a bit of context, the Oculus portal is essentially mission control. And this is what the people on the ground station can see. Yep. So I'm going to share this screen right now. Interesting. Okay. It says it's sharing. All right. That's what it says on this end. Yeah. One of the downsides of working with very prototype technology is that it likes to fritz out whenever you need it most.
Do you guys want to show the video that we looked at earlier?
Yes. Do you know what that is?
YouTube channel.
All right.
Astronauts need new ways to get information, tackle complex challenges, and collaborate with those on Earth.
It's not sharing right now. Go ahead and reshare the screen and then start the video over.
For sure. Yep. There's. So this video is an overview of what we've done in the
Astronauts need
past.
new ways to get information, tackle complex challenges, and collaborate with those on Earth. Introducing ARSIS 4.0, which seamlessly integrates augmented reality, virtual reality, and a desktop portal to create a cohesive mixed reality experience we are calling telepresence. This is achieved with 3 separate applications that run in unison and share spatial mapping data over a network.
Okay. All right, perfect. So we're just gonna kind of cannibalize this video to show what this system is about. So this first thing you're seeing right here, the left side is the portal for the mission control, which is a virtual reality portal. And then the right side is the astronauts portal, which is augmented reality. So we can see that the mission control portal is currently putting down arrow icons onto the ground. And we're going to see those shortly in the augmented reality. We can see those up in the real world. And that's useful for directing towards certain things. In the upper left-hand corner, there's the mini map there, which will rotate with your facing and help guide the astronaut towards points of interest, in this case, a beacon. You can see that you've now gotten 20 meters away from the beacon that you started out at. It also shows the direction towards it. So it's a very robust system. We can see that there's lots of different things that the mission control can add, both icons or lines that can be used to make drawings or text. Right here, let's see if we can see some of the other functionality here. All right. right, so that's navigation via the minimap. You can just walk towards the areas. And these orbs we see in the sky are the beacons. The blue one here and the red one right nearby, anyway. And that could be set to any location on the map. The blue and the red aren't important. You can change the colors. And that's just a way for astronauts to be able to navigate from point to point. Here we see the biometrics menu pulled up. It's currently, everything is flashing red because it is not connected to NASA's telemetry stream. During actual tests, we're going to receive information, and that information can be used to determine if the simulated suit is low on oxygen or any other number of biometrics that could cause hazard or jeopardy to the mission. So now we're looking into the procedures menu. And the procedures menu has some neat functionality. Like up in the corner, you see there's an option to follow. But right now, we're going to go through just one of the procedures. And let's see
The field node system can be
if
used to
we've
capture
got this. Yeah, so the voice control is fully integrated with the procedure system as well as the field node system. And that helps us navigate it through with it hands-free. So this is going to be the field node system or the geology sampling system. It's the same, we just don't really have one name for it, which walks through a questionnaire to make sure that the astronaut can see exactly what sort of rock or interesting geology they're dealing with. And this information can be sent back to mission control. Yeah, that rock that we chose does not actually fit very many of these field nodes because it's not a rock, but it is what it is. All right, so we got the questionnaire, we can create a voice recording, and then finally, at the end, there's an option to take a picture. And this is done entirely with the augmented reality system, which is super cool in person. And so you just essentially look at the thing and say, take a picture, and then it does. And then finally, so this is the mission control portal from inside the mission control. And you can see the lines up there that represent the pillars in the space that the astronaut is, or the simulated astronaut in the augmented reality system is in. And you can draw or place icons here in this. And it's not completely random because you can see where in space these things show up for the astronaut. And one of the, not priorities, but one of the things we're focusing on here in the near future is making this area seem more realistic, taking in color data and whatnot. So it's a little bit easier to visualize what's going on. Then, yeah, so there's lots of different options for navigating the space. Mission control isn't confined to the ground. They can fly through the air or grow in size or shrink in order to do whatever is necessary. So right now, you see they zoom out in order to put a larger or longer path in place for the astronaut. And that's something you can do from this portal. You don't have to do it all from first-person perspective. And then the astronaut can follow the path, just like that. I believe those are the functionalities that are shown off in this video. And ground station is working?
So just check and see if it's casting.
All right. Let's check. Okay.
There it is.
So we've got one of them.
I'm gonna have you put this on, and then I'm gonna start or something.
Excellent. Perfect. So we have the ground station working right now with our streaming software. Sometimes it doesn't like playing nice because it's just trying to do its job and it doesn't like to have all of that information transferred over a network. In-person demonstrations are usually much better for this. And I'll turn the floor over to them.
All right, sorry about that technical snafu. I overwhelmed our network and it was too much going on at once. So we're gonna do one screen at a time. So what you're seeing is the VR ground station we've been talking about. And so this is what NASA would be using back on the ground. Here in a little bit, you're going to start seeing meshes come through of the room that we're in that have been captured by the Hololens in real time. So that should start happening right about now. I'm gonna walk around the room to get a nice map of the room.
Yes. So we can see the ceiling and the chairs and the pillars are starting to come in. And that little purple pill is our astronaut. Yeah, the mesh is coming through.
Cool. All right, perfect. All right, so you can kind of see the room here. We'll call that good enough for now, just for demo's sake. Now, the cool thing is that the person in VR,
Yeah, sure.
All right. So I just need you to draw some stuff. So.
Yep.
All right, so he's going to start drawing some stuff with the tools that we've built for the ground station. And so this is where they can draw arrows and give directions and annotate the environment. Give like some arrows.
Okay.
Yeah, and so the idea is that you could use the arrows to guide someone to a location and make them, go like, hey, go here, go check this out, and then have them do a field sample. Also put them a little lower. So right now they're like above my head. Just like that. Anyways, yeah, and so you can like make directions to guide someone somewhere, and then they can make a very obvious annotation by like putting circles or squares or X's on things to designate like, hey, this is the spot you need to sample. And they can draw like a big arrow pointing towards it and say like, oh, sample here. Or they could go so far as to be like, hey, like you need to exit this room, like go this way. And so the advantage of that is that if the astronaut has a hard time seeing something or is perceptually blinded somehow and doesn't know exactly what's going on, then they can use the guidance from mission control to help guide them around in a more organized fashion. Yeah, definitely a pretty interesting deal. So now that you've seen the ground station end of things, we're going to switch the view. All right. We're going to show you what I'm seeing in the HoloLens. Okay. Maybe we'll show you what's going on in the HoloLens. This is always the thing that's difficult, where if it's in person, it's easier because we can just put the headset on you. All right, there we go. Cool. It's gonna do this again, isn't it? I really don't enjoy this. All right. Okay, there we go. Sorry about that delay there, but now you should be able to see what I'm seeing in the HoloLens. You can see these arrows that you placed earlier. And so I can follow these around. There we go.
All right, yes. And currently, this is just one use of telestration, is to create paths like this. Though that is not the only use for telestration. We can also see you can label things. There is a text box function, but I haven't used it before, so I didn't want to risk it. All right. So yeah, you can put things in, I'll slide into screen. You can put things into the astronaut's field of vision in that way, which can be useful for lots of things. And right now, Caleb's showing off the field note technology or feature by looking at our sample that we created. Not much of a sample, but there it is. He took a note about it. Now that's something that can now be accessed by mission control. And we see it right there. And it's not going to show the telestration in the field note because we figured that would be confusing if you were actually trying to take pictures of real rocks. So now it's pulling up this menu and recording a path. We can see this path is being put down. Everywhere that Caleb goes, it's recording the path behind him. And this can be useful for backtracking your steps or any other number of things. And that's a tool we came up with for that. Right? Then while he's still playing with that, you can see the mini map up in the corner, and that helps navigate towards the different points of interest. Those points don't actually match up to anything in the real world right now because they were hard-coded in for a test we did earlier with NASA. So one of the priorities this year that we've already mentioned is making it so that you can update those maps on the fly to make them relevant to the mission. All right, this is the procedures list. Currently, we have several procedures to choose from, and we can go through them in various ways. And we're almost out of time. Is there anything else that we really want to show them?
I think that's all the big stuff. Anyone's got any questions?
All right, yeah, so we'll open up the floor to a question and answer. And now that we have these windows working, we might be able to show you anything you have questions about.
That's fantastic. Oh my goodness. I wish we were there in person so that we could give you a huge applause for the work that you guys have put into this incredible project. This is, so we have a couple of questions, and please feel free to continue adding questions to the chat as we finish here. I'm sure there's a whole bunch of them kind of muffled in your heads. Please share them and then we'll share them out with you as well. But I just want to start by saying, you know, I was watching Prometheus with my husband last night. We're big sci-fi watchers, and this looks like what was happening in a sci-fi movie. I mean, they were coming down to a planet. The captain was looking on a screen just like this and telling them what to do. There are geologists down there collecting samples. And it's really amazing that this is something that I see in sci-fi things and you guys have actually created. So I guess my initial question is, you know, what inspired these elements? Was there any inspiration from what we've seen in the movies?
Almost certainly. Augmented and virtual reality as a field is largely inspired by sci-fi. Like, not even 5 years ago, virtual reality was not a thing that was in popular use. There were a couple of prototypes. They didn't work very well, and they were incredibly expensive. But just them showing up in sci-fi all this time, you got older sci-fi from all sorts of eras have some form of virtual reality or augmented reality overlay. And that's been a huge inspiration in building this whole field. So I wouldn't doubt that any individual application of extended reality is based off sci-fi at some point. This specifically, we've been inspired by sci-fi on some of our features, but the overall test, I can't really speak for how it was inspired because NASA came up with it.
I can.
Oh,
it's definitely Iron Man. So so literally, so the suit projects. This is like we're developing software, but they're at NASA. They're building the hardware to actually display the augmented reality in the spacesuit. And that suit project where they're actually building the real hardware, it's called the Jarvis project, and it is definitely based off of Iron Man. Like one of the people running the project literally said that during a meeting. Like it's for, like they saw Iron Man and they went, hey, we need that, but in space, and started working on it.
That's fantastic. Oh, that's so exciting. I love it whenever art inspires reality and they all get mixed in there together. Wonderful. Well, we have a couple of questions, and please continue to bring more in. The first one is, so when you're putting these together, do you meet or work directly with astronauts to test your program or devices, or does NASA oversee the direct testing?
All right, so we have a former astronaut who's actually the advisor for our club. So we get to talk a lot about what would actually be useful in space, Dr. Steve Swanson. Most years we actually get to go down to, which space center? It's the Johnson, right?
JSC, yeah, Johnson Space Center.
Yeah, most years we get to go down to the Johnson Space Center to test these after they're built. We don't get to test with astronauts while we're building it though. So it's more of a big event at the end. Because of COVID last year, we had to mail down the hardware and they tested it virtually. And we were on a video call with them at that time.
That's cool.
Yeah.
And then another question is, how did you guys get involved with this program?
Like us, the team, or us individually?
Yeah, I think you guys individually is, I think, what the intention of the question was.
I mean, I've got kind of I can give a little spiel there.
Alrighty.
So like for me, I was originally in computer science and I liked it, but I didn't love it. And then I found a new degree here called GIM, and that's what Kai and I are in. I really enjoyed it. It felt like it was a lot of applied software development for me. I really enjoyed it. And through that, I actually met Dr. Karen Dottie, one of our professors in the program, and she's the one that got me on the suits team. She was like, hey, you should come to a meeting and come check it out. And so I did, just for the heck of it, just to see what it was all about. And here I am 3 years later. But yeah, definitely been a really fun learning experience. I've probably learned more from working on this project than I have from arguably my whole college degree. So definitely worth it.
For sure. I forget who exactly recommended it to me. I think I just saw it on one of the GIM Discord channels. So sort of an instant relay chat we use between all of the different people in the GIM program. And we just use that. Somebody mentioned suits. I'm like, oh, that's interesting. So then I checked it out and I'm like, wow, this is actually something I want to do. So I joined the team.
And I was looking for lectures to go to and happened upon this one seminar where the team presented, and I've always been a huge fan of NASA and the things they do related to space. And so as soon as they said NASA groups, I was immediately interested and ended up joining this one because I like the opportunities to expand my current knowledge because I'm a mechanical engineering major. But it's a lot in software and augmented reality, so it's a good expanding of my current field of knowledge.
That's fantastic. Thank you guys. One other question too is, so this is created for use in space, particularly, but are there uses, or have you guys kind of thought or talked or brainstormed uses on Earth as well, ways that we could use it here in various capacities?
So many. Caleb's got a good one.
There's a lot. So one of the first ones I ever thought of was construction. Be very useful for construction inspections and things like that. You would remove a lot of the travel time that you need getting these specialists to a bunch of different job sites because they could just remotely inspect it. But beyond that, actually recently, earlier I was mentioning outreach events that we've done, and one of them was it was the Titanic night at the Discovery Center. I think they called it the Unsinkable Night. And so one of the things that we were doing during our presentation there was talking about how this software could be modified and implemented in deep sea exploration, and how they could use this. In theory, a lot of things like NASA has astronauts and aquanauts, which go into the water. And so the idea is that they could adapt this technology for usage by aquanauts for undersea exploration, given some technical modifications. But yeah, and so there's a lot of possibilities. I mean, and that's just scratching the surface. I mean, realistically, you could apply this to just about everything. I mean, I've seen technology similar to this being applied to the medical industry for like real complicated surgeries and things like that. And yeah, a lot of really cool, useful possibilities there.
Oh, that's fantastic. That's wonderful. And a new job, Aquanaut, to look forward to. So there's lots of, for all of our younger viewers, I mean, we've got geologists and astronauts and game developers and computer scientists and mechanical engineers. There's such a wealth of different careers within all of the STEM fields that can do really cool things like this and create projects that are inspired by none other than Iron Man, which is just really exciting. So I don't see any other questions coming through. Is there anything that the three of you guys would like to share with us before we end our program today?
Sure. So anybody that's looking into getting a career, as you mentioned, younger viewers, I think that there's a lot of fun opportunities in augmented and virtual reality. That's definitely something to look into if that's something you're excited to do, because all the tools we use, with the exception of the hardware itself, that's something you can actually download and play with right now if you want to. So that's a good thing for high school students or some middle school students just to get into. And game design as a career, a lot of people think that it's not very useful or it's just all for play. But a lot of those tools translate very well into useful techniques, especially in augmented and virtual reality. Like I'm a games major, but I don't see myself making games with my career. So those aren't necessarily wasted skills if your child wants to learn how to program games or whatever. Like I say, let them. Especially because even if they don't wind up using those tools specifically to create augmented or virtual reality experiences, the programming required to make games is actually huge. Almost everybody I know that's doing a CS major programmed games at some point as a kid.
Kind of to add to that, if anyone, especially for you younger folks, if you're interested in going towards like, looking at maybe trying out like an internship with NASA or something at some point, look at their challenges that they have going on now. There's a lot of challenges from NASA that I didn't know about for a long time that go all the way down to grade school levels. I'm working as a mentor actually this semester and a little bit next semester for a high school challenge where they're building an application to map routes along the moon and maintain radio signal with Earth. And that's something that they're building in Unity. Again, it's using these free tools that we use to build stuff like this. It's very similar. So it's good experience, and at the end of the day, it gives you a little bit of street cred with NASA, kind of. I mean, you're working on projects that they want you to work on. You're solving their challenges, and at the end of the day, you're in and around people that work with NASA. So you're learning a lot from them. You're learning a lot about the process and making good network connections while you're there. And yeah, it's definitely something I'd recommend trying out. Also, if you do look at like internships and stuff, apply while you're still in high school. I didn't do that because I didn't think they took anyone from high school. And it turns out they actually take a lot of people from high school. They actually prefer that. If you're someone that is like shows initiative and drive in high school and like has some real interest in things, they want that, and they will teach you what they want you to know. They'll send you where they want to send you, and they'll take care of all that. They just want people that are driven. And so definitely, like I'd say, look into that stuff. I waited too long to look into it, and I wish I'd done it sooner. But yeah.
Great. Oh, this is fantastic. Well, I hope that everyone is leaving this as inspired as I am. I mean, this is just really exciting. And it's exciting to know that this is happening right here at Boise State University and that we're surrounded by such intelligent, talented, wonderful people that are making a difference in the world. So thank you guys for the work that you're doing. And we wish you all the best in the challenge and can't wait to hear more about all of the incredible things that you guys are developing. So thank you again for coming. And just for everyone, thank you for joining us today. We love having these programs and highlighting all of the incredible work that's being done by people in our community in the STEM fields. And this video will be available on YouTube later on today so that you can watch it again, or you can share it with family and friends who weren't able to join us today at lunch. And with that, please stay curious and come join us at the Discovery Center of Idaho next chance you get. Thank you so much, and everyone have a wonderful rest of your day.
Thank you.
Thank you. Bye.